Let's take a look at an example for integral test. Here you have a series which is n times e to the power negative n squared. Let's try to see if we can apply integral test for this function or not. So the function that you see is f of x equals to x e to the power negative x squared. We need to check to see if the function is continuous, decreasing, and positive on the given interval, which is in this scenario 1 to positive infinity. This function is x multiplied by the exponential function. You can use Desmos and check to see if this function is above x-axis or not. Let's take a look at Desmos together. Let me open up Desmos. There we go. We are on Desmos and we're going to graph x times e to the power negative x squared. Negative x squared. This is the function that you're dealing with. Between 1 to positive infinity, as you can see, the graph is above x-axis, or it's in positive part of y-axis. It is touching, but if you zoom, you can see it's not negative. So you basically have a positive function. So far, so good. So check mark, let me use a different color. It is positive. Is it continuous? Just check the graph. You can also say that, hey, I have x times e to the power negative x squared. There is no asymptotes. So basically, you have a well-behaved function. It is continuous. There's no gap, there's no hold, there's no jump, so it is continuous. Now for decreasing part, you need to take the derivative of this function. You need to show algebra to check to see if it's decreasing. So on the exam, on the homework, make sure to show step-by-step work to show that this function is decreasing. We need to show that the derivative is negative. Some students say, why you don't just compare the terms? You might have a different behavior for your function on the finite numbers of terms, and then it starts changing the behavior, as you can see in this example. So if you go back and take a look at the general behavior of this function, you see a huge change. The function was increasing, then starts decreasing. So it's super important to use a different technique, a different test, like taking the derivative of this function and make sure you are showing that the derivative is negative. So basically you can say in general, this function is decreasing on what interval? So since you have the multiplication between two functions, we're going to use product. Product rule, remember that if you have fg prime, it is f prime g plus fg prime. So here you have x times e to the power negative x squared derivative. So you have the derivative of x times e to the power negative x squared plus x times the derivative of negative x squared derivative. The derivative of x is just 1. So you have 1 times e to the power negative x squared plus x times, for this guy, you have to use chain rule, negative 2x e to the power negative x squared. So let me open a box here for you. If you have e to the power u, and I ask you to find the derivative, you're going to say that it is u prime e to the power u. So in this case, you have e to the power negative x squared. You have to take the derivative of negative x squared times e to the power negative x squared, which we already know it is negative 2x. So we have negative 2x e to the power negative x squared, as you see here. Now let's check to see what do we have. We have e to the power negative x squared. I factor out negative e to the power negative x squared. I end up with 1 minus 2x squared. So we factor out e to power negative x squared. Why I did that? Because this function, this is going to be above x-axis. Take a look at e to power negative x squared. Going back to Desmos, and we're going to see what is the behavior e to power negative x squared. E to power negative x squared, this function is always above x-axis. All right. If you take the limit, the end behavior goes to 0. So this function is always positive. The only thing deciding about the sign of your derivative is going to be 1 minus 2x squared. 1 minus 2x squared. Well, take a look. You have a parabola. This parabola is above x-axis between these 2 points. And it is below x-axis negative infinity to this point and this point to positive infinity. So this is the behavior of this derivative, which is basically a function. That's why we graph this. Now take a look. This guy is always positive. Always positive. But for this function, which is basically a parabola, let's go back to Desmos again. I just want to show you this. So from 1 to positive infinity, the function is below x-axis. The y values are all negative. It means that this combination, which is positive times negative, when x is more than 1, or that point, is going to be always negative. When x is more than 1, this combination, positive times negative, is negative. So we just check to see if this function is continuous, positive, decreasing. All of them are true on this interval. Now what? Do we stop? Of course not. Now we need to find the integral. If the integral exists, we say that, hey, the series is convergent. Otherwise, the series is divergent. So let me erase the rest of the board. So far, we showed that f is continuous, decreasing, and positive on 1 to positive infinity. Now we calculate the integral. This part is important for us. The integral 1 to infinity of x e to power negative x squared dx, we can use u solve, right? U is equal to negative x squared, du is negative 2x dx. So dx times x is du divided by negative 2. Wherever you see dx, you can x dx, you can substitute that with du divided by negative 2. So this is the integral of e to u du divided by negative 2. But the integral of e to u du is e to u plus c, right? Here we have definite integral. We can just convert this back into x and use whatever we have. We have 1 divided by 2 with a negative sign, and e to power u, which is negative x squared. X ranges between 1 to positive infinity, which is easy to calculate for us. This is equal to negative 1/2. 1 divided by e to power x squared. X ranges between 1 to infinity. So you have negative 1/2, 1 divided by e to power infinity, or just basically infinity, which is 0 minus 1 divided by e to power 1. So this guy is equal to 1 over 2e. So this integral is convergent to this value. We conclude that the series is also convergent. So this is our conclusion. So since the integral 1 to infinity of x e to power negative x squared dx is convergent, we conclude that this series n e to power negative n squared and starts from 1 to infinity is also convergent.